Dynaudio Focus is the first loudspeaker in the world that has Dirac Live built into the loudspeakers. Dirac Live is room correction software that allows you to do measurements in your room, do a correction curve based on those measurements, and upload that correction curve to the loudspeakers to improve the sound that you're experiencing in your actual room. Dirac Live is a third-party software. It requires a PC or a Mac to use the software. There's some components you need to get Dirac up and running on the Focus speakers. First of all, a pair of Focus speakers that is running the latest firmware, which it should be doing automatically. You need the latest version of Dirac Live software, which is downloaded from dirac.com. You need a Dirac Live license specifically for the Dynaudio Focus speakers. Again, you purchase that through the software itself. You also need a microphone. Specifically, we recommend a USB microphone, which is called Mini DSP UMIC 1, which is available from many outlets on the internet. There are other microphones that can be used, but this is a relatively cheap microphone that is highly recommended for this particular use. And you should also have a full-size microphone stand to use together with the microphone to be able to make measurements without having anything obstructing the measurements between the speaker and the microphone. There's actually two versions of the Dirac Live license that you can purchase from Dirac. One is a limited bandwidth version that allows you to do corrections up to 500 Hz. If you only want to correct the bass response, that's a possibility. The current price is $159 for that license. There's also a full bandwidth license where you can correct the full frequency response in your living room. And the price for that is $249. So the first step is setup preparation. So what you need to do is connect the USB microphone to your computer. Make sure you have the latest version of Dirac Live. Make sure the speakers are updated to the latest firmware. Make sure that Dynaudio Focus speakers are connected to the same network as the computer, since the communication between the software and the speakers will be done all through the network. You need to place the microphone in the main listening position at ear level, and the microphone should be pointing upwards towards the ceiling because you're measuring the room response, you're not measuring the loudspeaker directly. You need to make sure that doors or windows in the listening room are closed, basically to avoid background noise affecting the measurements. Once you start up the Dirac Live software, you need to log in with your account and ensure you have the license up and running. And then within the software, you'll be presented with a screen where you can select the loudspeaker to do the correction for. And then you basically click the logo for the loudspeaker to start doing the measurements. If you don't see a loudspeaker on the screen, there's a button called IP where you can put in the IP address of the specific speaker so that it can search directly for the IP address. Depending on your network settings, that might be necessary. But usually just click the button. The next screen is a setup screen where you set up the microphone to use for the calibrations. So here again, you should be choosing the UMIC 1 microphone. You need to make sure that you're using a calibration file. So the UMIC 1 comes with a calibration file that you can download from MiniDSP's website. When you load the calibration file, from MiniDSP you will have two correction files. One is the standard file where the microphone is pointed towards the loudspeaker, and the other one is a 90-degree file for when the microphone is pointing upwards. And in this case, we want to measure the room, so the microphone is pointing upwards, so you need to select the 90-degree calibration file. Once you do that, you proceed to volume calibration. So this is where we make sure that the loudspeakers is playing at a volume where you can measure the loudspeakers without having background noise affecting the measurements. So I have a few settings here that are available. You have a master volume where you can basically set the max output of the loudspeakers. This should generally not be set above -40 dB for a Focus speaker, unless it's really necessary to get above background noise. But try to aim for -40. And you should never go above -24 in any cases. But we recommend -40 dB. You can also adjust the microphone gain. That really depends on the computer. Sometimes it's different between PC and Mac. But basically make sure that when you're testing the output of the loudspeaker, you have a reasonable level of output compared to noise. Once the volume calibration is done, you proceed to the seating arrangement. So Dirac allows you to choose from 3 different types of seating arrangement. One is called focused imaging. You also have one which is wide imaging and one which is tightly focused imaging. That depends on your preference in terms of, do you want to optimize the sound for one listener position, the main listener position, or you want to have a broader scope where more people will have better sound. In general, we recommend to use the tightly focused if you want the best stereo performance for one listener in the sweet spot. And that's typically what most people interested in high quality hi-fi wants to do. So normally that's what we recommend doing. If you wish to have a broader scope with better sound from more people in different listening areas, you can choose from one of the other seating arrangements. Once you have selected your preferred seating arrangement, you proceed to measure. So this is where you're actually carrying out the measurements of the loudspeaker. So in order to learn about your room, you need to measure the response in different places in your room. So the first measurement is done by simply pressing the button, and you will hear a sweep from first the left speaker, then the right speaker, and then the left speaker again for validation. Now the Dirac Live software will show you a frequency curve from that measurement, and it shows you the response for each speaker. But this particular response is not that relevant in and of itself just yet. What the software then will do is it will guide you through other places to put the microphone. So the best thing you could do is follow the guide, and for instance, the first next measurement will be in upper right. So when you look at the picture, you can imagine placing the microphone about half a meter away from the main listening position to the upper right. And then do another measurement there, which is done in the same way. And then you basically go through all of these different measurement positions. Just follow the guide and do what Dirac tells you to do in terms of making these measurements. And these measurements are then combined into the final actual response in your listening room. You should do at least 5 measurements. The software will go from 9 up to 13 measurements depending on the seating arrangement. But as long as you make at least 5, then you're usually good to go. Once the measurements are done, you proceed to filter design. So this is where we take those measurements and then build a filter correction that is actually uploaded to the speaker. And this is where the change to the speaker reproduction actually happens. In the filter design process, you will see the curve as it has been measured in your room, and then you'll see a yellow target curve. This target curve is what we are then trying to correct the speaker to reach that you can kind of adjust to make the best sound in your listening room. So Dirac has a suggestion that you can try to use, and you can basically proceed to filter export using that measurement, or you can change the tweeter level up and down, you can change the bass level up and down to set your own target curve, so to speak, before you move forward. Another thing you can do is you can select a manual target curve. So rather than just adjusting bass and treble level, you can grab individual points in the target curve to create a target curve that specifically works for you and your room. It takes a little bit of experimentation to figure out which one you like and which one works best in your room. But once you start working with it, you easily get an idea of what actually happens to the sound when I change any of these things. One more thing to note is that you can also adjust the frequency range that you want to correct. There are different opinions on this. Some people want to correct the whole frequency response. Some people prefer to only correct the bass response. So you can basically drag the windows left or right to select which range do I actually want to correct. Once you have done this, you're ready to proceed to the filter export section. So this is where you're actually uploading the corrections to the loudspeaker. You actually have 6 different memory settings in the Dynaudio Focus. So what you do is select one of the memory slots. You can give it a name and a description so you can remember what you actually did for this particular target curve. And then you press export filter, and then that's uploaded to the speaker. And then you can actually go back, try to do a different target curve with different settings, and save that to a different memory slot. So once all of this is done, you can start listening to your loudspeaker, select the different memory slots, figure out which version you like the best. Maybe you want a memory setting that has a different bass level for like evening listening where you don't want the bass to be too loud. Whatever you want to do, you can create these different settings and then choose from them. It's also a good tool just to figure out which version you like the best, to have different candidates and then select between them as you're listening to figure out how to optimize the sound specifically. Once you're done with the calibration, make sure to save the project on your computer, because then you can always go back to the same project and play around with target curves and upload that to the speaker without doing new measurements in your room. If you want to delete some of the memories that you have created, you need to do that inside the Dirac software. So on the left side, you can see each of the memory settings, and you can just press the red X button to delete one of the memories if you want to. So there are some best practices when you're doing a room correction like this, specifically for Dirac. So how do I get the best results? First of all, Dirac can aid you if the speakers are not in the perfect position, but the result will be better if you try to position the speaker as good as possible before doing the correction. And Dirac can actually help with that, because when you're doing the first measurement in the main listening position, it shows you the measurement in that specific position. So if you take a look at that curve and try moving the loudspeaker and do another measurement in the same position, you can compare those measurements to see which one actually gives the best response. And then you can use that as a starting point before you proceed to doing the other measurements. So that can actually help you in terms of optimizing the sound in your room. One of the things we would like to encourage you to do is try working with these target curves, because they actually do significantly alter the experience of the sound. There's not a single target curve that will work for every room. So because of the reverb in different rooms is different and the room sizes are different, what sounds most natural will not be the same curve in every room. So what you actually should do is try to figure out, okay, how do I get a natural sounding response without having peaks or dips in the response? So if you're listening to a track with variable bass, all of the bass notes from like a bass guitar should be as even as possible, but the amount of bass is more or less selected by your target curve. So you'll have to be careful in doing these setups. One thing you should keep in mind is not to use the target curve to overly boost the low end. Just because you like bass, there's a limit to how much bass the speaker actually can deliver, no matter how you set the bass response. So if you turn up the bass too much, you won't be able to play as loud, because there's a physical limit to what the speaker can do. Use the target curve to kind of match the natural sound in your room, not to just boost bass just because bass is fun. One of the things you can do is you can actually set a delay for each of the measurements. So you can physically leave the room while the measurement is going on and then come back once the measurement is finished. So that's a nice feature to make sure that you get the best measurement responses. The last thing of note is when you have done these correction curves and you've done the measurements, you might be a little scared to see how those curves, it's not a perfectly flat line. So the perfect flat lines you see in the marketing papers, that is done in an anechoic environment, so with no reflection from walls at all. So that looks very clean. But once you measure the sound in room, you have a lot of reflections from all of your walls, floor and ceilings. And that curve is always not as nice looking. But what matters in the end is how it sounds, not how that curve looks. A dip in a specific frequency is not as audible as you might think when you're looking at the curve. Some of the questions that might arise: can a measurement microphone be connected directly to the focus speakers? And the answer is no. The microphone needs to be connected directly to the laptop. That's how the Dirac software works. There is a Dirac iOS Android app. So why can't I use that with the speakers? Well, that app is designed specifically for products that are designed to have the microphone directly connected to the loudspeaker. But that's typically not the same quality of microphones, and the best result is done by this version of Dirac that has the microphone connected directly to the computer, so that's the one we recommend using. Will Dirac correct the signal of the subwoofer output of the Focus? No, the current version corrects the speakers only. So Dirac is actually disabled if you enable subwoofer in the Focus speakers. Does the Dirac correction filter add a delay to the signal? And the answer is yes. The way the filters work, they need a little time to work, because Dirac corrects phase as well as frequency response. And to do this, it adds a slight delay to the signal. So if you have a video source, you need to be aware that there might be a difference in time between the image and the sound. So we designed the Dynaudio Focus speaker, just like we design all Dynaudio speakers, to work optimally in an average room, because we don't know what your room is. So what you can do with Dirac is that you can align the speaker system to work specifically in your room. So you shouldn't think about it as a correction of something that's wrong. It's just what happens when you place a speaker in your room, that your room affects the sound. So using Dirac, we align that response to work perfectly for your specific room, so you get the best sound in that room. Hopefully this video has helped you in figuring out how to set up the Dynaudio Focus for your specific room. It's really easier than it sounds once you look at it, once you get the software up and running and start working with it. If this process seems daunting to you, we have a dealer network that are willing to help you in terms of setting up your focus speakers and doing the direct calibration for you. So if you're not up to doing this yourself, please contact your dealer and they will help you out.